Okay, so now we're going to come back to section 2.6 and we're solving matrices or systems of equations with matrices. And I kind of wanted to review a couple, and then we're going to get into what happens when we have a quadratic, when we have an x squared or a y squared that we're solving for. So here I just wanted to review a little bit of, okay, how do we solve this? So if we look at problem number 9, and this was from the worksheet that we have, I just want to give an example. What we do to solve this is we'd say 7, -3, 1, 2. I'm looking at the coefficients for my x and my y, and I want to take the inverse of that matrix multiplied by 4, -14. So it multiplied by the constant matrix that's on the other side. So what I'm going to need to do is I need to get to my calculator. I'm going to clear everything off here. I need to put those two matrices into my calculator. So I'm going to go in, I'm going to edit my A matrix. I want it to be a 2 by 2 matrix. And the 2 by 2 matrix, if you remember, it was 7, -3, 1, and 2. I need to quit out now. Once I have those in, I want to put in now my B matrix. So I'm going to go over, I'm going to put in my B matrix, and if you remember that B matrix, it was a 2 by 2, and it was 14, or excuse me, it was 4. I misspoke. One more over, I need to delete that. It was 4, -14 was the other one, so -14. I'm going to enter that. And then I'm going to quit out. All right, now I'm going to see if I can find the answer to that. So I needed to take the A matrix right here. I needed to take the inverse of that. That's my A inverse, and I need to multiply it by my B matrix. Here's my B matrix, and there's my answer. Sorry, I have to enter one more time. There's my answer, -2, -6. Okay? So if I go back here, I can say, oh, by the way, now I know my answer is -2, -6, which means that the point that solves these two is the point -2, -6. Also means that x must equal -2 and y equals -6 is the one point that solves them both. Now let me show you just how I would set up the other one. Just kind of quickly going over it. It's 3, -2, 12, -8. I would take the inverse, sorry, I kind of went too quickly here. I would take the inverse of this first matrix and multiply it by 940, okay? So again, I would go through the exact same process on the calculator and multiply it. Now with number 10 though, when I've entered in, I entered in my matrix for matrix A, and here it is, I've entered it in. That's the same matrix, 3, -2, 12, -8. And I entered in my matrix for matrix B. Here that is, it was 940, all right. And then I went to go do my A inverse B. This is what I get, all right. So what happened is the determinant of my original matrix doesn't work. This happens to be a matrix that is they're either parallel lines, and actually this one turns out to be parallel lines, or piggyback lines. So if you ever get this, don't think that necessarily you made a mistake. This one, for this particular problem, the answer is that we have parallel lines and there's no solution. All right, so it's either that there's going to be infinite solutions or no solutions. This one is the answer is that there's no solution. So don't think that necessarily an error message means you made a mistake or that you plugged in something wrong. So that was your assignment from yesterday. So let's talk about, okay, what happens when we have x squares and y squares? When you have all x squares and y squares, you can solve it a lot like you've solved the matrix that you've been working with. And so here we have 1, we have 3, we have 2, 1, and if you remember what we're solving for is x squared and y squared, and that equals 57/34. All right, so to solve this, we take the inverse of our first matrix and we multiply it by our second matrix. I'm going to go ahead and do that. So I've entered in this was the error message from before. I've entered in my A and my B. My A was 1, 3, 2, 1, and then my B equation was 57 over 34. So now I want to do, my second enter gives me that A inverse B. Let's see what we get for an answer. We get the answer 916. So what does that mean? That means that our x squared, y squared matrix equals 9 over 16. Does that mean that's our answer? Well, in this case, the answer, that's no. It doesn't mean it's our answer. What it means is that x squared is really 9, and that y squared we found to be 16. But to solve this, we'd have to say, well, if x squared is 9, what is x? Well, if x squared is 9, x could either have been a positive or a negative 9, because, or excuse me, not 9, positive or a negative 3. Because negative 3 times negative 3 would give us this 9, and positive 3 would give us the 9. Y, same thing. Y could have been a plus or a minus 4. So we found for this particular problem that our y is either a positive 3 or a negative 3, and or a positive 3, negative 3 for x, and our y could be a positive or negative 4. So the way that we show this, probably the most common, most popular way that we show this is we just show it like this, plus or minus 3, comma, plus or minus 4. If we went and showed all the different combinations, you'd actually have to say, okay, it could be 3, 4. It could be negative 3, positive 4. It could be negative 3, negative 4. And then the last option is positive 3, negative 4. So there's just, you're really actually showing 4 possible answers there. That any of these combinations, when you look at the original equation, will give us a true statement there for the original equation. So when you have an x squared and a y squared, be very cautious that you just don't think, okay, I plug it into my calculator and that's my answer. Remember, you have to take the square root and we have to take the plus minus of the square root. So be cautious of that. Now that's the case when you have an x squared and a y squared. What if only one of them, equation-wise, is squared? In the second equation, we have an x and a y squared. But in the first equation, we just have an x. Then you know what? You're out of luck. As far as you can't solve it that way. In order to solve this one, you're going to have to use substitution. So for this problem, I would use substitution. And I'd say, well, x is really 1. I already figured out what x is. So in my solving it, I just need to figure out what y is that solves this. And so I'm going to use the fact that I know x can be replaced with a 1. I look at my second equation, y squared equals 49 minus x squared. Well, we've already figured out x squared is a 1, is a positive 1. So y squared is really 49 minus 1. Y squared is really 48. Well, if y squared is 48, y is the square root, and it's plus or minus the square root of 48. And that's all we put here is plus or minus the square root of 48. Sometimes they look pretty, sometimes they don't. And that's our answer. That's okay for our answer here. Okay? Let's do another example from today's homework. So here's our homework. I just threw in 4 more problems here. Let's look at the first problem here, number 6. So I'm going to solve number 6 here. Number 6, I would start with my second equation, because I'm looking at the first equation, x squared plus y squared equals 16. Okay, a lot of different combinations we could use there. But with the x plus 2y is equal 10, I'm going to say that x is really a negative 2y plus 10. So I solved my second equation for x. That now I can say x can be replaced with negative 2y plus 10. My first equation, I have x squared plus y squared equals 16. Well, if x can be replaced with this, I'm going to go ahead and do that. I'm going to replace my x with negative 2y plus 10. Now remember that this isn't 4y squared plus 100. Please, please, please tell me that you remember that. What we need to do here is we need to take negative 2y plus 10 times negative 2y plus 10 to square that. And here we have plus y squared. Sometimes it works out and it'll all work out in the end. Sometimes it is a little icky. This looks a little icky. But we'll figure it out. All right, so first, negative 2y times negative 2y is 4y squared. Outside, negative 2y times a positive 10 is negative 20y. Inside is another negative 20y. Last is plus 100. We still have our plus y squared, and that equals 16. All right, well, we still have a quadratic that we're trying to solve here. We need to figure out what y equals all by itself. So we're going to combine like terms. We have 5y squared minus 40y plus 100 equals 16. All right. I'm going to get everything. I'm going to set it equal to 0. So setting it equal to 0, 5y squared minus 40y, I'm going to subtract 16 from both sides. So that turns out to be 84 equals 0 here. Now we have to solve this. We have to remember what we did in Algebra 2 to solve this. And I think the best way to do this is to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I think that's just the quickest way to solve this. So in this case, negative b would be 40 plus or minus the square root. B squared would be 40 times 40 of 1600 minus 4 times 5 times 84 all over 2 times 5. I'm going to need to even extend my page a little bit more. So now I have some multiplication to do here. Let's take this. We have 40 plus or minus. I'm going to take 4 times 5 is 20 times 84, and I get 1,680. Oh, this is really an icky question or icky problem. I get negative 80 in here all over 10. Solve it, leave it there. Oh, that turned out to be kind of a longer involved and ickier than I was hoping for. So that's our answer. Go ahead and leave it. We could simplify it. Definitely could simplify that square root of negative 80. That's not what we're working toward here, though. I'd say go ahead and leave it like this. Okay? Thanks, and we'll come back to this idea in a review.